Now, principle of operation of motor. That means here principle of here objectives are the principal operation of synchronous motor and the methods of starting, characteristics of features of synchronous motors. It is known that when two analog poles are brought near each other, there exists force of attraction between the two poles. Between the two poles. So the two magnets are now said to be magnetically locked as shown in figure. Here these are two different poles. That means here unlike poles, here north and south poles are given. There will be existence of attraction force. When attraction force is up here, that is said to be magnetically locked. That is magnetically locked. Here, if one of the magnets is rotated, the other one also starts rotating in the same direction with the same speed as in shown figure. So here the conditions is referred to as magnetic locking. The conditions is referred to as magnetic locking. See here. So magnet N and magnet 1 and magnet 2. So magnet 1 rotation enough and magnet 2 also rotates. When it is magnetic locking. When it is magnetic locking, then only it will be rotate. So principle of when a three-phase winding is fed by a three-phase supply, a magnetic flux of constant magnitude but rotating at synchronous speed is produced. So a magnetic flux of constant magnitude but rotating at synchronous speed is produced. Here the working principle of synchronous motor. Here the stator, in the stator there are slots, in that slots the winding is wounded, slots, and this is the rotor with some two poles. So here the supply is AC. So here the supply is AC. Here also in figure. And working principle of synchronous motor. So observe this one. So very carefully. So see here. North to south with the synchronous speed. Working principle of synchronous motors. See observe this one. So when three-phase supply is given to the armature winding, so armature establishes a constant magnitude of the rotating magnetic field. So here the fields rotates at synchronous speed in air gap. See observe this one. So that is the air gap, that is the magnetic field. So rotating magnetic field, and that speed is synchronous speed. So it establishes the armature establishes a constant magnetic magnitude of rotating magnetic field. It is a constant. It is rotating with synchronous speed. Here stator poles marked by NS and SS. These are rotating at synchronous speed, say these are rotating at synchronous speed, say clockwise direction, clockwise direction. The direction is in clockwise direction. Say observe this one, the direction. When rotor is excited with DC supply, the DC supply to the rotor. So here the rotor winding establishes constant magnetic poles on pole shoe, on pole shoe. At the instant of positive off cycle, here NS at point A and SSS at point B. Here NR at point A and SR at point B. See observe this one. At this instant, similar two poles are repel each other, hence rotor try to rotate in anti-clockwise direction at the instant of immediate negative off cycle. Here SS at point A and NS at point B. So NR is just away from A and SR just away from B. Consider a two-pole stator shown in figure. Here stator poles marked by NS and SS, and these are rotating at synchronous speed. Saying it is in clockwise direction. Now the rotor poles are at that instant situated at point A and B are marked by N and S. So now here in figure the two similar poles N of rotor and Ns of stator as well as Ss will repel each other. The rotor thus tends to rotate in the anticlockwise direction. Stator, here see in the figure, the stator, it is a salient pole machine. The stator is shown in the figure, and in the stators the slots are and a three-phase supply, and here using the salient pole, the marked NS at N, SS at S. Rotor is wound with the field, that is the winding is called field winding. So here supply is DC supply. This is the figure as shown given the diagram. Next, so but half period later the stator poles having rotated around interchange their positions. So now under these conditions NS attracts S and SS attracts N as shown in figure. So NS is stator field speed, SS is stator north pole and stator south pole. N means rotor speed of north pole, rotor north pole, and S means here rotor south pole. So see, observe this one. Observe this one. Carefully, yes, stator and rotor. What are the differences here? NS, SS, and S, A, B, and the direction. How they given direction. So the direction of rotor. and as north for north pole and south pole. So are the different diagrams. See, observe this at the stator side. And this is also a diagram for the rotation of the rotor. It's owing to its large inertia, it cannot instantaneously respond to quickly reserving torques. So it remains stationary. So it remains stationary. Next, starting of synchronous motor. So observe this one, starting of synchronous motor. So here prime mover is attached to the synchronous rotor at starting time. See, observe this one very carefully. This is the prime mover attached to the next starting. See here, observe this one. So DC supply for the rotor, it establishes the field poles at rotor side, and the three phase supply NS, and here see the performance of a synchronous motor on load. Here three phase supply, net VA is equal to armature voltage, that is equal to applied voltage minus back EMF. Here IA is equal to armature current is equal to V minus EB by ZA. ZA is equal to RA plus JXS. This is the on load. Here the performance of synchronous motor on load, hence the rotor trends to rotate clockwise, which is just reverse of the first direction. Hence we find that due to continuous and rapid rotation of stator poles, the rotor is subjected to a torque, so which is rapidly reversing in quick sessions. So now the rotor is subjected to torque which tends to move at first in one direction and then in the opposite direction. So the rotor cannot instantaneously respond to kick reversing torque due to its large inertia. So the results is that rotor remain stationary. So here the rotor is on one side for fast to access for one moment is one direction, in another moment is opposite direction. So it will be result gives that remains stationary. it fluctuating, then after that it will stationary. Therefore, the motor is not self-starting. A two-pole rotor running at constant speed is shown below. The methods of starting: the rotor is speed up to synchronous speed by some arrangement and then excited by the DC source. The moment this near synchronously rotating rotor is excited, it is magnetically locked in position with stator. The rotor poles are engaged with the stator poles and both run synchronously in the same direction. So, characteristics, features of synchronous motor. Here the synchronous motor runs at synchronous speed only. It is not inherently self-starting. It can be operated over wide range of power factor, both lagging and leading. So, summary, what we have discussed about till now. So, principle of operation of synchronous motor and method of startings and characteristics, features of synchronous motor. This is about the summary.